Agarwal this side. I hope you all are fine at your places. We were discussing about chapter 8 motion in grade 9. As we have already discussed motion, types of motion, distance, displacement, scalar quantity, vector quantity. Now we will be discussing about speed, velocity, average speed and average velocity, acceleration, deceleration, equation of motions, their graphical representations, and of course problems or numericals based upon that. See, speed is a scalar quantity. इसको याद रखने का तरीका है S for speed, S for scalar, V for velocity, V for vector. Speed is scalar quantity, that is distance upon time, while average speed is total distance traveled divided by total time taken. जो आपके ऑटोमोबाइल्स में स्पीडोमीटर होता है वो हर टाइम की स्पीड बताता है, राइट? तो वो एवरेज स्पीड नहीं बताता. आप जिस टाइम चेक करते हैं वो उसी टाइम की स्पीड बताएगा, इतने किलोमीटर पर आवर. So if you want to calculate the average speed, then you have to add all the distances covered divided by the total time taken. Or the formula will be S upon T. Here S is not speed, it's distance. Then velocity. Velocity is displacement upon time taken. If you talk about average velocity, then average velocity is what? Again, the addition of this. So this is initial velocity plus final velocity divided by 2. Initial means starting, this starting velocity. And mathematical expression is u plus v divided by 2. See, if displacement is 0, then average velocity will also be 0. In automobiles, see, there is a circle kind of instrument in which speedometer and odometer both are present. Odometer tells you the distance covered. Now acceleration. If you change the velocity of your automobile or of your cycle or any object, then the rate of change of velocity is called acceleration. Because velocity is vector quantity, so acceleration is also vector quantity. See, we are talking rate of change of velocity, that is change in velocity divided by time. So acceleration is final velocity minus initial velocity divided by time. If we talk about the units, this is change in velocity. So the unit of velocity is what? Meter per second divided by time. Time is what? Second. So the formula will be meter upon second square, that is meter second inverse square is the SI unit of acceleration. If velocity increases, then acceleration. If velocity decreases, then this is called deceleration or retardation. Now numerical based upon this concept. This is a numerical. First of all, I want to tell you what is the method of solving any numerical, whether this is in physics, chemistry, biology, geography, economics, mathematics, anything. First of all, read the statement and then read the statement slowly. See, starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of bicycle comes down to 4 meters per second in the next 5 seconds. Calculate the acceleration of bicycle in both the cases. तो ये न्यूमेरिकल रीड करने के बाद आपके माइंड में क्या आया कि एक्सेलरेशन और वेलोसिटी से रिलेटेड कोई क्वेश्चन है, तो फटाफट जाओ चैप्टर में कॉन्सेप्ट पे, फिर सोचो कि आपको क्या क्या आता है एंड देन स्टार्ट राइटिंग. स्टार्टिंग फ्रॉम अ स्टेशनरी पोजीशन मीन्स स्टॉप्ड, that is initial velocity is 0. Rahul pedals his bicycle to attain a velocity of 6 meters per second, means final velocity is 6 meters per second in 30 seconds, that is time is 30 seconds. See, either write seconds or S, don't write SEC. This is not the way. Many of the people do it, but that is not right. So this is. Now what is to be asked? Acceleration. Acceleration के लिए I know only one formula, that is v minus u upon t. So what is v? 6 minus 0 divided by 30. 6 by 30. 1 by 5. 0.2 units meter per second, second. 0.2 meter per second square in case 1. Now case 2. Then he applies brakes. See, he applies brakes. Generally, whenever we drive car, what we do? In car I am talking about. Acceleration, brake, clutch. When you press accelerator, velocity or speed increases. When you remove your foot, then what happens? You press brakes. Means acceleration is getting decreased. That is retardation. So one case will be acceleration, other case will be deceleration. See, earlier the velocity was 6 meter per second, then he applied brakes and the velocity was 4 meter. So here initial velocity is what? 6 meter per second. Final velocity is what? 4 meter per second. Time is what? Next 5 seconds. 5s. So acceleration is what? V minus u upon t. That is 4 minus 6 upon 5. Minus 2 upon 5. Minus 0.4 meter per second square. Again the units will remain the same. Meter per second in second. Meter per second upon second. See here, minus signifies deceleration. Alright, so here acceleration is 0.2 meter per second square, while here deceleration is 0.4 meter per second square. As I have already told you that if you want to prove it, then consider it the part of this trapezium is made up of two parts, rectangle and triangle. And if you are proving third equation, then let it be trapezium only. OABC, this figure. So distance S is area under OABC. OABC is what? Trapezium. What is the area of trapezium? The sum of parallel lines into the distance, the perpendicular distance between them divided by 2. So half of sum of parallel lines into perpendicular distance between the parallel lines. So S is what? Half of sum of parallel lines OA plus BC into distance OC. OC is what? Small t. OA is what? Small u, initial velocity. BC is what? That is final velocity. So u plus v into t divided by 2. But now we rearrange the value of t. As we know, v minus u upon t is what? A. So just rearrange it. T is what? V minus u upon a. So this value of t is to be put here. V minus u upon a. So now this is S is equal to u plus v into v minus u upon 2a. Just rearrange it. V plus u, v minus u upon 2a. You know a plus b into a minus b is what? A square minus b square. That is v square minus u square upon 2a is equal to s. Just rearrange it. 2as is equal to v square minus u square. That is third equation of motion. That was all about the graphical representations of equations of motion. We will prove these equations of motions by graph, which we call graphical representations of equation of motion. First of all, take velocity time graph. Here we are not starting the velocity from 0 point, rather we are starting the velocity from some point, right? So this is initial velocity and then velocity increases and it reaches up to point B. So this is initial velocity and this one is up to B is final velocity. See this one. This is final velocity OE and this is initial velocity OA. If you draw perpendicular from B to x-axis, it will meet it at C. So BC is a perpendicular and we are just extrapolating this AD. This is parallel to OC and equal to OC. Here OA is equal to CD. So BC consists of BD and DC. Now see, initial velocity is what? OA, that is U, and OA is equal to DC. Final velocity is OE, V, final velocity, and this is equal to BC. While BC is made up of BD plus DC and DC is what? U. So here V is equal to BD plus U, BD is V minus U. We'll be using this equation, that's why we calculated it. Now time T, OC, and OC is equal to AD. Slope of velocity time graph is what? Acceleration. And slope of any graph is what? Perpendicular upon base. Perpendicular is what? BD. Base is what? AD. BD upon AD. BD you already know, V minus U. AD you know, OC, that is time T. So V minus U upon OC, that is V minus U upon T. V minus U is what? Change in velocity upon time, and you already know change in velocity upon time is what? Acceleration. Hence proved the slope of this graph is what? Acceleration. V minus U upon T is equal to A. Just rearrange this equation. V minus U is what? AT. V is what? U plus AT. That is first equation of motion. Now graphs, graphical representations. Velocity time graph. If we plot a graph and take time at x-axis and velocity at y-axis, and this is quite uniform velocity, 20 meter per second in first, second, third, fourth second, everywhere it is the same. So if I calculate the area under it, that is area under velocity time graph, then it will be what? Area of this rectangle. Area of rectangle is what? Breadth into length. Breadth is what? Velocity, and length is what? Time. So velocity into time is what? Displacement. And if we take this velocity, speed instead of this velocity and time, then the area under speed time graph is what? Distance, because distance is what? Speed into time. So area under a velocity time graph or speed time graph is distance. If we take changing velocity and see this velocity is being changed very uniformly, so this is uniform acceleration. So this axis is velocity and this axis is time in seconds. If we take the area under this is what? Trapezium. Trapezium area of this rectangle plus area of this triangle. So it will be that area under it is what? Again the same, distance or displacement. So whether this is uniform or non-uniform, that will remain the same. But if we take the gradient, that is the slope. Slope is what? Tangent. That is perpendicular upon base. Perpendicular is what? Velocity. Base is what? Time. So here the slope or gradient of this velocity time graph represents the acceleration, because this axis upon this axis. This is what? Change in velocity, and this is what? Time. So change in velocity upon time is what? Acceleration. Now equations of uniform acceleration. In our syllabus there are three equations. Equation number 1, V is equal to U plus AT. Equation number 2, S is equal to UT plus half AT square. Equation number 3, 2AS is equal to V square minus U square, where V is final velocity, U is initial velocity, A is acceleration, T is time, S is distance. Okay? Watch this video twice, read the book, and then attempt all the questions. By that time, stay home, stay safe. Bye-bye.